Welcome to MT 116, Algebra for the Real World, Chapter 1.1. First, we're going to be going over a situation called parking problem. This is going to follow Activity 1.1 in your textbook as we go through these PowerPoint slides. The data on the first page of your textbook relates the number of cars in the parking lot with the time of day at a typical community college. You may want to find this data in your textbook now. Okay. Here is a slide with the actual data from page 1. The situation involves two variables, the time of day and the number of cars in the parking lot. So variable 1, time of day, variable 2, number of cars. Typically, one variable is called the input and the other is called the output. The input value is the given value that is given first, and the output is the value determined by the given input value. In the parking lot situation, looking at this table, can you determine the input and the output variable? Okay. The input is what was given first, so the time of day, and the output is going to be the number of cars in the parking lot. Okay, so let's think of an example. For an input of 6 p.m., how many cars are in the parking lot? So we're looking for an output value that corresponds to an input value of 6 p.m. And then additionally, let's think about for each specific time of day, how many different outputs or number of cars are there? So looking at the table again, for an input of 6 p.m., how many cars are in the parking lot? So remember, we identified the time of day as our input and the number of cars is our output. For an input of 6 p.m., our output is 427. Now for each specific time of day, how many different outputs are there? Number of cars. So at 7 a.m., only 24 cars are associated with it. 8 a.m. is 212, 9 a.m. is 384. So each input corresponds to one and only one output. Okay, so I want to focus on this second half. This is very important. So again, for each specific time of day, there was only one output for each input value. This set of data is an example of a mathematical function. Functions is going to be our main focus of this chapter. Okay, so what is a function? In order to be a function, you need to look at the input values. So our time of day, for example. Each input has to have one unique output value. If any one input value has more than one output value, then it's not going to be considered a function. So for example, if at 9 a.m. there were 384 cars in the lot, and then there was another 9 a.m. with 402 cars in the lot, the relationship would not be a function, because an input of 9 a.m. cannot go to two different values. So this would be not a function. So let's talk about a verbal representation of a function. To state this parking lot situation verbally, you would say that the number of cars in the parking lot, which is the output value, is a function of the time of day input variable. So in general, the output variable is a function of the input variable. This statement should be memorized. let's think about interchanging the input and the output. So if you switch the input and the output values of the parking lot situation, do you still have a function? So essentially what we're asking, is the time of day a function of the number of cars in the lot? Well, let's look at the table. So we're now going to say that the number of cars is our input and the time of day is our output. Looking, we have the number 384 three different times. So we have three inputs. 384 goes to an output of 9 a.m., 1 p.m., and 7 p.m. So the output of 384 goes to three different inputs. So no, this is not going to be considered a function. Remember, a function, each input value has one unique output value. Our input of 384 had 7 p.m., 1 p.m., and 9 a.m. as our outputs. So no, we cannot interchange input and output in this situation. Okay, so let's look at a couple of examples. And let's determine whether each situation represents a function. The amount of property tax you have to pay is a function of the assessed value of the house. I'm going to put a box around the word function. What comes after the word function, so assessed value, is our input. What comes before the word function, so property tax, is our output. Is this a function? And this is going to be a function. So let's think, if you live in, let's say, West Seneca, and your taxes are 7%, and it's going to be for everyone, so no matter what your assessed value of the house is, a house that's worth $100,000 times 7% is going to give you one unique value, one output. And that's going to be the same for any assessed value of the house. Once you multiply it by the tax rate, you're going to get one unique amount. So yes, this is a function. Okay, another example. Determine if the weight of a letter in ounces is a function of the postage paid for mailing the letter. Okay, so here's our word function. Postage paid is an input, and ounces, the weight of the letter, is our output. So let's think about this. If you have a letter and you put it in the mail, and let's say it's a birthday card, that's going to take one forever stamp. Now let's say you have the same birthday card, but now you have pictures in it. It is also going to only cost you one forever stamp. These cards are going to have different weights, but they still cost the same. So this is not a function because the same postage applies to two different weights. Okay? So, function notation. Verbally, we could say for the parking lot situation, the number of cars in the parking lot is a function of the time of day. Function, the input comes after the word function, and the output is before the word function. In function notation, we would use a letter. For example, F. We like to use F because the word function begins with the letter F to be the name of the function we're talking about. We use a letter T to represent time and the letter C to represent the number of cars in the lot. So we would read this notation as C equals F of T. The number of cars in the parking lot, C, is a function of the time of day, T. So in general, function notation is written like this. Output equals the name of the function, input variable. So our cars was equal to the function f of the time of day, which was our input variable. Okay, write a sentence explaining the meaning of f of 16 equals 278 in the parking lot situation. Okay, well, remember we equaled our output, which was the number of cars in the lot, and this was our input, which was time. So there are 278 cars in the lot at 1,600 hours. So 1,600 hours, they're actually talking about it in military time. So 1,600 minus 1,200 is 4 p.m. So at 4 p.m. there are 278 cars. Thank you.